Hey guys, Mr. Milton here. Today we're looking at parallel lines notes. At the end of this video, you should be able to identify parallel lines from characteristics in their equations, and you should be able to write the equations of a line when given information about a parallel line. Okay, so here we'll start off with graphing. It says graph both of these lines on the same coordinate plane. So first line is in slope-intercept form. Our y-intercept is 6. 1, 2, 3, 4, 5, 6. Our slope is -3/4, so we'll go down 3. 1, 2, 3 over 4. 1, 2, 3, 4. And I can't do that again. Okay, that's it. I'm going to make my line that goes through these two. Okay, so that's my first line. Let me erase this excess line there, okay? And now for my second line, I have 6x plus 8y equals 16. As I look at 6 and 16, it looks like I'm going to get a fractional x-intercept, so I'm going to put it in slope-intercept form instead. And so I'm going to subtract 6x from both sides. I have 8y then equals -6x plus 16. All right, then I'm dividing by 8 to get y all the way by itself. And so y will be -6 over 8. Simplifies to -3 over 4, so -3/4. X plus 16 over 8 is 2. So my y-intercept is 2. -3/4, so I go down 1, 2, 3 over 1, 2, 3, 4. I can do that again, but I can't fit it there. I can go up 3, 1, 2, 3, and left 1, 2, 3, 4. There we go. Bring my ruler back out. And as I make that line, boom, 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 my two lines. All right, so as we look, it says, what do the two lines have in common? Okay, so here's our first equation, and here's our second equation. What do the two lines have in common? Well, looking at their formula, or their equation, we see that both lines have the same slope. Okay, the slope is -3/4. What's different about the lines? Well, the y-intercept. In the first line, the y-intercept is 6. In our second line, our y-intercept was 2. So to summarize, using the last two questions, the characteristics of parallel lines. Okay, and so we didn't really talk about it, but look, these lines don't touch. They're going the same direction. As they continue on forever, they will never intersect. These are called parallel lines. Parallel lines have the same slope and different y-intercepts. Same slope and different y-intercepts. Okay. So as we go through, that's what we'll be looking for to determine if two lines are parallel. Okay, we will not have to graph them every time. We'll know if they're parallel because they'll have the same slope and a different y-intercept. Now, typically how these problems are set up is that they give you one problem where you can identify the slope and y-intercept pretty quickly, or one equation where you can, and then the other equation where you cannot. Okay, remember that we can only identify the slope and y-intercept by appearance in slope-intercept form. Okay, so in this first problem, they give us our line in slope-intercept form, y equals 2x minus 1. In this line, our slope is 2, and my y-intercept is -1. Okay, in the second problem, our second equation, I need to get y by itself before I know that. Okay, so I need to subtract 2x from both sides, and y equals -2x plus 3. And so for this line, my slope is -2, and my y-intercept is 3. Okay. Now the directions for the section say determine whether the given lines are parallel or not, then explain. Remember, for parallel lines, we have to have the same slope and a different y-intercept. Here, our slopes are not the same, right? We had to subtract 2x. We couldn't just pick this up and move it over there. We had to subtract it, and that's why it's negative on this side. So are these two lines parallel? No. Different slopes. Okay. Over here, we have two equations again. Here, the second equation this time, they actually gave us the slope as 5/2, and our y-intercept as -4. Okay, so I have that information already. In our first equation, they gave us 5x minus 2y equals 8. So again, we're going to need to solve for the y-intercept. Or sorry, solve for slope-intercept form so we can see the slope and y-intercept. So here I have 5x minus 2y equals 8. I'm going to subtract 5x from both sides. Start getting y by itself. Gives me -2y equals -5x plus 8. Divide then by -2. And so I get y equals negative divided by negative is positive. 5/2 x negative or positive 8 divided by -2 is -4. Okay, so as we look at our slope is 5/2. It's the same. Our y-intercept is -4. It's the same. Are these lines parallel? No. Okay, you might be like, wait, the slope was the same. Yes, the slope was the same, but also the y-intercept was the same. These lines aren't parallel. They're the same line. Okay, and so what that means is when we talk about parallel lines never touching, the same line is going to be right on top of each other. It's going to touch in every point. So cannot be parallel. Okay. Finally, number 3, we have 8x plus 6y equals 30. And we are going to put this in slope-intercept form. Notice that even if we're asked a question like this, even if we could find the x and y intercept with even numbers, we would choose to put it in slope-intercept form because then we would be able to identify quicker the slope and y-intercept, which is the crux of our lines parallel, right? The characteristics of parallel lines is that they have the same slope and different y-intercepts. And both of those pieces of information are visible in slope-intercept form. Okay, so let's find that. We have 8x plus 6y equals 30. I'm going to put y by itself to get it into slope-intercept form. 6y equals -8x plus 30. Divide by 6. That's y equals, looks like it's going to be -4/3 x plus 5. So for this first line, my slope is -4/3. My y-intercept is 5. For my second line, my slope is -4/3, and my y-intercept is -5. Are these lines parallel? Yes. For what reasons? They have the same slope and different y-intercepts. Okay. And there you have it. All right, so identifying slopes or identifying if lines are parallel, that's what we're looking for. Now let's go to a different type of problem. And in this type of problem, we're trying to write the equation of a parallel line. So here it says, write the equation of the line parallel to y equals -3x plus 4 that goes through the point 7, -2. So here's our process. We're going to find the slope of the original line. Okay, as we look at this problem, this is nice. They gave it to us in slope-intercept form. We know what the slope is. It's the number that's by x. Remember, it does not include x. Our slope is -3 because it's in slope-intercept form. Now we're going to find the slope of the new line. And we do that with knowing what we have to know. If the line's parallel, it has the same slope. So if our original line was -3, then the slope of our new line is -3. Now it says find the y-intercept using the point. So just like when we wrote the equation of a line through 2 points, it's really now the same process. We have the equation y equals mx plus b. The coordinates of our point are 7, negative 2. We know what our slope is, right? We've already determined that it must be negative 3. We have the point 7, negative 2, so we plug those where they go. Negative 2 is our y value, 7 is our x value, and b we don't know. So we're looking for. Okay? So now, negative 3 times 7 is negative 21. This is b. Add 21 to both sides to get b by itself. And that gives us 19. So our y-intercept is 19. Our slope is negative 3. The equation of our line then, y equals negative 3x plus 19. Same type of problem. The difference here is that at the beginning of the problem, notice that our equation is in standard form. We can tell it's in standard form because x and y are on the same side, right? And we cannot identify the slope in standard form. We don't identify the slope in standard form. We will put it into slope-intercept form first. So that means we're solving for y. And so I'll subtract 2x from both sides. Gives me negative 4y equals negative 2x plus 11. To get y all the way by itself, I'm dividing everything by negative 4. So that gives me y equals negative 2 divided by negative 4 is positive 1/2 x. Here we'll get minus 11 over 4. Okay, and then some people get thrown off by this y-intercept. But remember that our first step is to find the slope of the original line. Do we have that information? Yes. The slope of our original line was 1/2. We're good. It really doesn't matter what the y-intercept is. Okay, so if it's not a nice number, that's okay. From there, we have to think, what's the slope of our new line? Well, since the lines are parallel, they have the same slope. So the slope of our new line is 1/2. Now we use the point 6, 1 to plug into y equals mx plus b to solve for our whole equation. So y1 equals m, which we found to be 1/2, x, which we found to be 6, plus b. Okay, and now we just solve for b. 1/2 times 6, 3. Subtract 3 from both sides, negative 2. So b is negative 2. My slope is 1/2. My b value, my y-intercept is negative 2. The equation of my line then is y equals 1/2 x minus 2. Okay. And finally, we can do that same thing if we're given a graph. Because remember, what we're looking for is the slope of our original line, the point that we're going through. And if we're given a graph, we're given that same information. So here it says, write the equation of the line parallel to the line shown that goes through the labeled point. So this line, they give us these 2 points. We have to find the slope. We can do that just by using a rise over run. You could find the coordinates, and this is negative 3, 6, I believe. And this is 3, 2. So you could use the points and do y2 minus y1 over x2 minus x1 to find the slope. But it's easier, remember, visually on a graph, just do rise over run. How's our rise to get from one point to the next? 1, 2, 3, 4. Negative 4. What's our run? 1, 2, 3, 4, 5, 6. 6. So our slope then, negative 4 over 6, or negative 2/3. So our slope is negative 2/3. If our lines are parallel, it will have the same slope. So negative 2/3 is the slope of our new line as well. Now we have to know what point does our new line go through. Well, our new line goes to the point negative 1, 2, 3, 4, 5, 6, negative 6. Negative 1, 2, 3, 4, 5, negative 5. Goes to the point negative 6, negative 5. And so now we do that whole process. y equals mx plus b. I know my y is -5. I know my m is -2/3. I know my x is -6. I don't know b. So -2/3 times -6 is 12/3, which is 4. I subtract 4 from both sides. And so I find my y-intercept is not -9. My slope is -2/3. The equation of my line then should be y equals -2/3 x minus 9. Okay, and there we have it, right in the equation of a line parallel to another line through a given point. See ya.